gain some insight, ideas, and experiences. Now, there are a long list of ideas that came up, long list of topics that came up during the course of the meeting, but basically these are the four categories: technical, programmatic, regulatory, and other hurdles. And I'll be going through a few of them. First of all, technical findings. Now, some of us, sometimes we forget to consider the whole system as the satellite development as a whole system. If the subsystem works, it does not necessarily means that when you integrate the total system, it will work. So when you integrate the subsystem, things might go wrong, and we have to keep that in mind. The design of this nanosatellite has to be kept simple. It might not seem very professional to have a simple coding structure. It might seem very plain and simple. But the thing is, the complex the design is the more difficult it is to debug. So it has to be very simple from the beginning. There are a lot of amateur radio operators throughout the world, and they are equipped with radio telemetries to assist our missions and to capture the data. And if we can set up a collaboration with them, it might be useful for universities to operate a nanosatellite within the short budget. Understanding the failure modes, things that can go wrong and things will go wrong. So we have to keep in mind all the things that can go wrong and how will they go wrong. So we have to plan ahead of time and think of the failure modes and how to overcome them. Say, for example, automatic hardware reset every 45 minutes or 1 month according to the mission requirement. And although there is a typical schedule for a satellite development, things doesn't always go according to plan. So there might be some delays, there might be some setbacks. So it will or it may take longer than expected. Programmatic problems, topics. We have to keep an open mind and try non-traditional sources for testing and other communication purpose. For example, off-the-shelf products might not be always available, so we might compromise and use the locally available materials. Many countries, it is very expensive to transport satellite from one university to other. So even there is a collaboration, it might not be always possible to transport your satellite for another continent for testing. So we might improvise some techniques, such as example for stress testing or vibration testing. You might stack up bricks on your satellite and see if that structure can handle it. Or for shock tests, you might try throwing your satellite off the table and see if it survives. So we talked about some ideas. And buying the components for a satellite might shorten the time period of your development, but it does not necessarily mean that it will make your development process any easier, because you still have to figure out how the system works, how the communication module works, and if they fit together, will they behave the way you want it to behave. Then prototypes out of recycled hardwares. First, to keep the cost minimum, we may try building our prototype with recycled hardware and locally available parts. That might keep the cost down. Legal and safety issues start early. Sometimes we are so concerned about the engineering challenges, we often forgot about the safety and licensing issues. And you have to register your radio frequency, you need to have papers for your launch safety, and the country has to take ownership of your satellite. So many of these paperworks involve governments, so it takes time. So it's better if you involve your government from the beginning of your development cycle. Documentation is very, very important. People may not be working in the same team for all of their lives, so they will be moving on to their next job, or they might be switching fields. But the next person who will be taking his position, he has to have some kind of documentation to carry on the mission. System engineer has a very critical role in the team. System engineer is the one who keeps the whole team together. So for example, electrical engineer might not understand what the mechanical engineer is saying or what is he doing. So a system engineer has to keep track of the whole team and make sure the team is on the right track. Learning process is more important in small scale satellites. Just because we have to launch a satellite into the orbit, that does not mean that you have to hurry up and just launch a piece of dud satellite or a dummy satellite into space, it will just create danger to other peoples. So these were basically it from our discussion. Thank you all.